Hey everyone, welcome back to the channel. Today's we are diving into one of the most fundamental topic in the machine learning, linear regression from the interview point of view. So if you are preparing for an interview in this field, then you will definitely want to stick around as we answer the five of the most commonly asked question related to linear regression. We'll be using the California housing dataset for this example. So let's get started. So the first question is pretty basic but essential, and that is the what is linear regression. So let me clear the output if there are some. Right. So linear regression is a statistical method, as you know, which is used for modeling the relationship between dependent variable and one or more independent variable. So the goal is to fit a linear equation to observe data that can be used to predict the dependent variable based on the independent variable. So in our case, we'll use the California housing dataset where we will predict the house price based on the features like median income, number of rooms, and more. So we'll use scikit-learn to load the data and fit the linear regression model. So let's first load our libraries, which include the NumPy, Matplotlib, and linear regression, and fetch California housing data to load the data, and train test split to split the data into test and training dataset. Next, let's load the California housing dataset and divide into X and Y. So X is the independent variables and Y is the target dependent variable, which is based on the X. Next, let's split the data into training and test. So we are splitting into test train, test, Y train, Y test. And we are keeping, let's increase to 30% of the data set. Next is creating a linear regression model. So directly calling the linear regression into a model and fitting the X test and Y test. So at this point, we have created a model and it learned from the test data set. Let's do our prediction and let's plot the X test means the actual value and Y predict the predicted value. So these are the predicted values as compared to the actual values. So this code load the California data set, fits the linear regression model, and then plot a comparison between the actual and predicted house. The next question, which is very common, is what is the cost function in the linear regression? So in the linear regression, the cost function is typically the mean square error, which measures the average of a square of the error between predicted and actual value. The goal of linear regression is to minimize this error. And mathematically, this is how it is being represented, where this part is the predicted value and y is the actual value. And we find the difference and do a square of this. And of course, the summation of all the values. M represent the number of training examples here. So to calculate the mean square error for our model, we'll load the mean square error from scikit-learn from the matrix and calculate MSE. So in this, mean square error is quite small, and so this gives a quantitative measure of how well the model is performing. A lower MSE indicates a better performance. Next question, which is also very important, it is what are the assumptions for linear regression? So let's talk about the assumption. So in linear regression relies on on a few key assumptions. So here are those. First one is the linearity. So there are linear relationship between the dependent and independent variable. So that is the first assumption. Second is independent of error. The residual errors are independent of each other, means they are not dependent on the different factors. Third is homogeneity, which the variance of the error is constant across all the values of independent variable. Number four is normality of errors, which means the residual of a model should follow normal distribution. And the last one is no multi-collinearity, means independent variable should not be highly correlated with each other. And to check the linearity, we can look at the residual plot. So for this, to calculate the residual, we have to check the true value and the predicted value and find a difference of it and plot with uh, the predicted value. So if I run this, so this will give me the residual versus the predicted value. So if the residual are randomly scattered around zero, it indicates that our assumptions are likely valid. Next, the other very important question which being asked in multiple interviews: what is overfitting in a linear regression and how to avoid it? So this is another question. Overfitting occurs when the model learns not only the underlying pattern but also noise from the training data set, and which leads to a poor generalization of on unseen data. It usually happens when the model is too complex or there are too many features. So to avoid the linear overfitting in linear regression, we mainly have two options. First, use a simpler model. Means don't use too many features if they are not meaningful. And the next one, which is more feasible, is techniques deregularization and techniques like regression, which is L2 regularization, and lasso regression, the L1 regularization. So this helps control overfitting by adding a penalty to the coefficient. So it's how you use the ridge uh, regression. So from the scikit-learn, we import the ridge, we create the model, and let's do a prediction. So as you can see, by adding the regulation, we penalize the large coefficient. So it helps the reducing overfitting. The final question we have for today is how do you evaluate the performance of a linear model? So there are several metrics you can use. The first one is the R square. So this indicates how well model explain the variance in the data, with value closer to one being better. And the second one, we have already seen the mean square error. The lower the MSC, the better the model. And let's calculate the matrix for our model. So MSC, we already done it. Let's do how to calculate R square score. So we can load this directly from scikit-learn and calculate. So as I told, the higher R-square value indicates that the model does a good job by explaining the variance in the housing price, which is the goal. And that's a wrap on the five uh, most important linear regression question you might face in your machine learning interviews. I hope this gives you a solid foundation and help you prepare for your upcoming interviews. Thank you for watching. I will see you in the next one.